So we're here at the headquarters of ficonTEC in Aachen, just outside Bremen in Germany, meeting with their CEO, Torsten Vahrenkamp. It means a lot to me to be here. It does mean a lot to me. This is a company that for many years has revolutionized the way that the industry sees optoelectronics manufacturing. And not only in Europe, but worldwide. I am very proud to say that in Europe we have created the supply chain of the best optoelectronic devices in the world, from design to manufacturing and assembly. Those devices are making a difference worldwide. And for that to happen, we needed a company like ficonTEC, bringing this technology to volume manufacturing lines. Torsten Vahrenkamp, on behalf of the board of directors of EPIC and the other 750 members, I had the honor and personal pleasure to award you with the EPIC CEO Award 2021. Thank you very much for your hard work.
Thank you so much. I cannot tell you how much that means to me. I'm very, very, very honored, and I still don't know. You have still to explain me how I deserve that. It's amazing. It means a lot to me. I'm super proud, and it's not an effort by myself, but it's amazing how this effort ficonTEC put into this industry is awarded now. So thank you so much. It is incredible how innovation through collaboration has brought success to ficonTEC. It's not only the innovation you have done, but how the ecosystem of photonics has benefited by that innovation. From the very beginning, that was an important part of your work, right? Collaborating and innovating with others. Because especially in that area where we are active, you only can win and progress when you collaborate with others. Because we automate the work of other innovators. That's the reason why I'm so amazed that we are recognized, or I'm recognized like that, because other people are doing the innovation. It's not necessarily us. We are just helping them to automate and industrialize their work. I want the audience to know you a bit better. So who is Torsten Vahrenkamp? Where did you study? Actually, I studied applied laser technology in Emden, which is like a small city close to the Netherlands border. And that time was one of the first universities in Germany. It was Fachhochschule related to optics and optoelectronics. And we were actually the second year doing this activity, and I'm one of those. And a lot of these former colleagues are now working at ficonTEC. When did you thought that photonics could be the industry in which you could make a difference? When was the first time you thought, oh, photonics is interesting for me? I was actually, I always wanted to be an electrical engineer. And as always, I was working as a DJ and light jockey when I was, and I always liked laser shows. And then there was these applied physics studies, and it was called applied laser technology. And so it sounds cool, so let's try that. I really cannot imagine you as a DJ. I really would like to see some pictures there. I can show you. I think one of the coolest things is that when I see the ficonTEC, and I had the pleasure, thank you very much for walking me around the manufacturing area, is when optoelectronics, photonics, mechanics, data, all of them come together to do innovation. So to come up with the idea of ficonTEC, you had to have a very multidisciplinary idea of how to bring this industry together. When was the first time you thought automation for manufacturing is where I can make a difference in this industry? I think when I started, I didn't have any idea what I have to expect. So this was when I started, this idea came actually when I was working for Siemens Public Networks, and I started that in '97, and we were installing for Siemens in Bangkok one of the most modern fiber optical networks, and we were supplied with optoelectronic components. And there was always a shortage of these devices. And I looked a little bit into it, why is that? And then I saw, okay, there's no automation for these things. And while I studied, and I was still writing my PhD thesis, and I was building laser lithography systems in the university. And I thought, you have this super high precision mechanics I'm doing in my PhD thesis, and on the other hand, there's a demand in the industry, and maybe we can do something in that direction. So, and that was the first. Is that without any research, without any market studies, I thought it may be a good idea to move into that area.
Just let's automate the process.
Let's automate something.
Let's try to bring some robots here who do from that dream to the idea. What was the first step? You are doing a PhD at a university,
which I never finished. So it was a PhD in mechatronics in the University of Loughborough, and as I said, I never finished it because ficonTEC grew too fast that time. So it took us from 97 to 2000. That was actually me and two colleagues, Felix Frischkorn and Matthias Trinker. We came together and we founded ficonTEC. So Felix Frischkorn more from the technical side, Matthias Trinker the finance and administrative expertise, who's still my partner up to today. And we actually founded the ficonTEC in Emden that time, and pretty much that was 2001. Now pretty much 20. This year we had 20th anniversary. So it's even
happy birthday. you founded the company while you were doing your PhD.
Yeah, but it was as I said, it was in parallel. So because it was a perfect time. You don't have money for. Or you didn't need too much money for a living, so it was a perfect time to start a company. So that's actually how it was born. And then we were running with the first product pretty much right away. So I was offering to customers that we have a mechanics which might automate their photonic assembly processes, and we found a company who believed in us. Who placed the first PO, and pretty much while they placed the first PO, the whole market collapsed.
Exactly, we are talking
2001. The first machine was ready in 2002. So we had this little team of 4 people, and there was literally no market anymore.
I finished my telecom engineering degree in 2001, so I know how difficult that time was for the whole photonic industry. It's really quite tough. How was it for you? So you were founding a company in 2001, and suddenly telecom bubble.
There was our main market was gone while we were still in the founding, or we were just founded, having the first machines, and the machines which we originally intended to sell for 200,000 euro. You could find like thousands of them, like for 20,000 euros. There was literally no market anymore.
So at that time, what most people would do would just close and go home and start something new.
I could have done that, yes, but no. We put our heads together, and we thought that the whole industry is, because all the engineers who were in telecommunication, all these wafer fabs and everybody, they were still there. So what did they do? They moved into high-power lasers. And we also moved into high-power lasers. So the first machines after the telecom machines were machines for stacking, unstacking high-power lasers, LIV test systems for high-power lasers, assembly systems for high-power lasers. So that was much slower than we originally...
But your idea was to go into the very high-volume production, because you were just Siemens, right? You were into the high-volume production, and now high-power lasers is at a lot lower volume.
Especially, but as I said, for us it was the grace in the sky, because actually we were not ready for very high volume. To be honest, there was the few stages we put together. We wrote our software while we sold the first system, so that we had no idea where we moved into. So, and the high power laser industry, it was small enough to grow with us, or we were growing with them. So we were, as I said, building LIV testers, building stacking systems, and we could do it at our own pace, growing slowly but steadily. And then there were other industries. There were a lot of defense contracts. There were a lot of things around this high power laser industry which were formed. Real photonics applications, nothing to do with telecom, datacom, but that was how we do. The bumpy road was as at every contract we acquired, and we had to fight so badly about, because there was no industry who really wanted to automate. So it was really us going there with I don't know how the English word is, Bauchladen. So kind of offering technologies. It's like, okay, we can do this, choose something. And it's like, okay, I want a little bit of that, And it was like, okay, how do we put that thing together, this customer wants? And it was really from everything we did was from scratch. And in the beginning was every time we got a new contract, it was reinventing the wheel. So, and kind of, it was very painful processes. And in that time we decided, okay, we need to do something completely different, because every machine we are selling is unique. And it will stay unique for the next couple of years, because there's no customer in that industry who wants the same thing again. So we came up with this super flexible software structure, which is still a big part of our business today, and the mechanical platform, which we are now able to change and modify quickly. Because that even having that in place, and it was a long time to develop that, it was still bumpy. Because you have to, every single contract, you have to go into the depth, and getting these machines accepted can take forever. Industry was going up and down until 2008. So 2008 we had already 45 employees, and then the world financial crisis came and hit us again. And that was very bad timing for us. We had the production floor full of machines. And from one day to the other, there was no orders coming in anymore. We didn't ship fast enough, so in the beginning of 2009, we had to declare bankruptcy, which was one of the hardest moments in my career so far. But we're still here because we found a way to survive even that.
2009, you declared bankruptcy. So once again, for the second time, most people would have said, okay, I close and I go home and I start something new. But you didn't.
No, it was not an option.
Determination.
First of all, everything we had, like my partner, Matthias Trinker and me, everything what we had was in that company. And I still remember when, in that time, when I asked my parents for 50 euros to buy me some food. So it was, but there was people waiting. So I asked our engineers to just don't go somewhere else. We will manage to reestablish this company. We went back to our customers if they would be able to place another down payment. And every single one of these customers believed in us, and they said, okay, yeah, let's do that. You have the machines there, you get the money, and that was actually how we restarted. And so that was end of 2009. And in that moment, beginning of 2010, it was kind of the thing start to run and ramp up in a speed which I would never be able to believe before.
45 employees, Matthias and you had to tell them that the company is declaring bankruptcy. How do you communicate that to 45 families at the end?
It's actually not only the time to communicate bankruptcy, but this time before was very hard, because everybody saw that we are in trouble, and we have a permanent communication. We try to be very open with everybody that we have these difficulties, but we also didn't leave any doubt open that we will manage to get the thing flying again. So that was important for us. So being with them on the phone for this 4 months where this company was not existing, to make sure everybody stays with us, because we needed them to restart.
In 2009, things started picking up because of 3 words: photonic integrated circuits. They were the key to the new era. We saw new designers, foundries, companies offering packaging and assembly services, and the emergence of first customers. But there was very little automation. That's where ficonTEC came in. But when did Torsten first hear about PICs?
I heard it already in 2001, so that there's something like that might come up, but it was far away from being ready. 2010 finally it was ready, but it took still until 15 that we built the first machines for that. In 2010 it was again high power lasers, a lot of things for hard drive industry like this HEMR, heat assisted magnetic recording. That was the first larger serial production of machines we did, and then there was the first integrated circuits showing up, and they needed to have fiber attached, they needed laser attached, they need lens attached, and so that was actually when we moved into that area. And then was also the numbers increasing, because first years like 12, 13, 14, there was one machine, two machines here and there, and then there was the larger orders coming in.
So what makes ficonTEC for me very special in this ecosystem is that from the very beginning you position the company in the center of the supply chain of photonic integrated circuits. Not at the end, not thinking, okay, when you had the device already designed, manufactured and tested, don't worry, I will automate the packaging. No, you put it in the middle. It was a time in which many people, 2010, 2011, many people were saying, when you design your chip, think about the package. And what made a huge difference, in my opinion, in the ecosystem is that your team communicated to the industry, don't think about the package, think about the machine that is going to manufacture that package.
And it's up to date, so it's very important.
And that made a difference in the photonic integrated circuit industry. How was it for you to interact with, at that time, 2014, 13, 12, interact with foundries that were developing a technology not fully mature, and they had to have the first packages, the first chips out, being packaged and tested?
It was pretty challenging because we not necessarily don't speak the language of that chip designers, and so we were trying to explain to them what we would do, and they had to adapt that into their into the chip designs and their package designs. So I really learned over the time to speak their language, and I'm really not theirs because I'm still not a PIC designer or package designer. But what we try to teach to our employees is to consult our customers in the way to make their product as manufacturable as possible. And the next step for us is having we trying to tweak our machines into a more standard manufacturing way. So having only a few platforms which are the same, and then you have different packaging ideas, and then you just adapt very quickly without redesigning the machine all the time. So that's important in order to get the price of the machine down, to become faster, because delivery times today is one of our major challenges. No customer in the industry wants to wait 40 weeks for machines. They are looking for 12 weeks, and that's where we have to be. Specifically with our larger customer in Asia, they don't wait. So this is our challenge.
I had to ask you this question. I have to, so please don't be upset. And you have photonics, integrated photonics, in my vision, in the future will be a semiconductor technology. Semiconductor technology is very used to passive alignment.
Yeah.
And you have been advocating for the use of active alignment, and you have demonstrated that active alignment can have the same manufacturing time as passive, or at least in the same scale time. Is it difficult to communicate to the semiconductor industry that if you want to add photonics, sometimes you have to add active alignment processes?
Actually, it's not, because if they use a passive bonder already for the accuracies they demand for the industry, they know how expensive that will become. It's like huge machines, very expensive, and difficult to maintain in terms of are they really meeting the accuracy over the whole production process? Building thousands of devices, because you cannot check in between if the process is working. With the active alignment, you see every device, the alignment is successful. And specifically, what's different from the semiconductor industry is you have to handle long devices. Even fiber studs, they're like little, like 10 centimeter long piece parts which are attached to your semiconductor. And normal semiconductor companies cannot deal with it. And that's where we come into play. And that's what we are, everything we do has, all the machines are made for that. We have specific magazines, we have parts handling, we have material handling processes which are made for these fibers. So this is what makes us very different. And the active alignment process, I'm still a strong believer, because that's our business, has a role, and it will not go away, because the machines are cheaper, they're not slower, and in my opinion, there's no way to seek for the holy grail of passive attachment.
The only reason why semiconductor was reluctant on using active alignment was because of throughput. You have proved that throughput is not a limiting factor when it comes to using active alignment. How? How did you prove that? Was it through collaborations, through research, through using better or faster tools?
It was a process over years. So when initially each device took us 3 minutes to assemble, which was unacceptable for a large and high volume manufacturing customer, they forced us to the target 30 seconds. And now the next step is going 15 seconds. And that's not only the machine which comes into play, it's also all the material which are around, like the glue, the epoxies, the curing methods, and potentially soldering processes. So all this you have to think about, and this is only something we can do in collaborations. It's not we do alone, we just provide the tools to support these processes.
For me, another very beautiful part of the history of ficonTEC is a bit recent. In the beginning, we were thinking always about packaging chips. And suddenly, when I talk to you, talk a lot about wafer level packaging. And then we talk about wafer level testing, about providing what you said before, helping your customer just making better products, making better devices. When was this change of mindset to go from not only doing the chip packaging, but also think wafer level?
It's actually demanded by our customers. So there were more and more customers coming and say, we have this wafers, why can't we do more on the wafer? Why do we have to dice it and singulate it before further process it? We want to do everything on the wafer itself. And I would say it's not there in the industry yet, but it's coming. So we have like right now about 10 projects simultaneously which are moving in this direction. Wafer level test, but also wafer level packaging. Active alignment on wafer level with laser soldering processes. So it's already working in our R&D center, and we have first customers who want machines for that process.
But right now, for me, this is the biggest challenge of the photonic integrated circuit industry, wafer level testing. You can quote me on that. The biggest challenge. Why? Because we are not sure what we have to test. We can do the IV measurement or we can do the LIV measurement, but most of the time we need to do customized testing. We don't really have a standard probe head, so there are many suppliers, many R&D areas to do. We don't have a standard. When did you realize, okay, if I want this to happen, I need to work with them, collaborate with them? When was for you the idea that this is a big business for my company, we need to invest time on this?
You know Ignacio very well, and Ignacio is the person who punished me fairly on a daily basis. You need to move into testing, and you need to do wafer level. So he has a strong background in that area, and he literally forced me to move into that direction, and I'm super happy that he did do that. So there's a lot of products we're shipping today which are based on what he forced me to do.
In 2017, we organized a meeting in Pisa, and there Ignacio Piacentini came to give a presentation about the idea that he had for ficonTEC doing wafer level testing. In that meeting, we had University of Southampton, we have Andrea Meloni, we had VLC Photonics, we had, and there a community started discussing, at that epic meeting, the community started discussing about how to automate wafer level testing. 3 years have passed, and now I can see ficonTEC machines at all these locations.
Exactly. I just want to say a lot of those people from that meeting are today our customers. So, and proud ficonTEC users.
This is the kind of thing that for me is innovation through collaboration, and in my personal opinion, that had a lot to do with that award on the table.
And as I said, without EPIC, we wouldn't be where we are today. So I have to say that because it's true. We were one of the very early members of EPIC, and it was always how do you get into a community as a startup? For me, it was impossible to. I don't know the people. Whereas and EPIC was always a platform where you always met the people, you talk to them, you have to mingle with them on the events, and it's always a fruitful outcome.
I want to ask now about the present. We are talking about bringing manufacturing capabilities, high volume manufacturing capabilities to companies that are addressing new markets, like the LiDAR, like the transceiver, the biosensing. Most of this manufacturing is not done in Europe, or is not going to be done in Europe, to be realistic. How was it for you to go to outside Europe to deploy these machines? I know that there is a big percentage of the machines that end up now in Asia, in the US. Yeah. When did you realize that ficonTEC was going to be a global company?
Fairly from the beginning, pretty much already in 2005, 2006, we had to employ the first machines in Asia because is that our biggest customers, the US customers, but they're also the manufacturing is done in Asia. And we have up to last year when it started to change, we didn't have large European organizations with large manufacturing plants. This is changing today, and I see that changing globally. So we are really seeing it's still a global market, but the manufacturing is moving back into the countries, into Europe, into US, and China, and Asia. So and this is what we as a company are doing right now. We are building up application labs in US. We just founded our application lab in Florida. We're building a large manufacturing site in China. Currently with a huge application space, and we are building a large team. So we have already 25 people in China now, and it's growing very fast. So all that it's super exciting.
Tell me about the Florida one. Right now you are setting up this location in Florida. Why did you decide for Florida?
We tested, or we talked to a lot of universities because we wanted to be close to a university to hire talents and who have Creole, the University of Central Florida, was very accommodating. They opened the doors for us and offered us space and a huge passion from their deans, and so we were excited to work with them. And there's a lot of customers around that area, so we thought it's warm.
Yeah, it is warm and it's nice, it's beautiful. It's not a bad place to go on holidays. And then you also selected a location in China, and you have big plans for China.
Yep.
Can you tell me a bit more about this?
Yeah, so in China was always for Chinese customers directly, so except the customers who are shipping machines to China from other countries, it was for us very difficult to attract Chinese customers directly, except for the R&D phase. So all the R&D centers and many of these larger telecom, datacom companies, they have our machines for R&D purposes, but the industrial processes are either homemade or done with lower cost Chinese companies. And we as ficonTEC, we need to take this challenge because it's our market. And that is the reason why we're building this manufacturing plant right now in China.
Which is a big challenge.
Yeah.
Culturally, the way that manufacturing is done there, changing the mindset, How are you going to address that challenge? I'm sure it's super exciting. I have to say that I have never seen you happier than when I see you in Shenzhen at CIOE, and then you're talking to very different people about the technology that you are trying to evangelize and advocate. How do you want to address that challenge? Tell me.
So there was this news this year that we actually collaborate with the company Robotechnik in China. So they are now also part of the shareholders of ficonTEC, because Matthias and I thought, okay, we need to do this step. We need to either we stall now in our growth path, or we expand into US and specifically China. And it was for us as individual persons, as a 100% owner of ficonTEC, too risky to do the steps completely by ourselves. So that's the reason why we decided to take up another shareholder. And with Robotechnik, we found a perfect partner who has already a big manufacturing plant in Suzhou in China, and they're helping us now to build a new ficonTEC in China.
ficonTEC, initially, we just heard that it's a company founded by two people, Matthias and Torsten. Torsten doing his PhD, and
never finished.
Which never finished. And it was a family company. I just met your dad when I was walking around the manufacturing floor. How does it feel now being a global company with locations in the US, in Estonia, in China, with a shareholder which is Robotechnik? So we are talking about big company. How does it feel? Do you get sometimes a bit nervous of what you are building, or are you still convinced that this is the best way to proceed?
There would be two ways you could see it. On one hand, you could leave it a small company like we were like maybe 10 years ago, and be in that size and be happy in that environment. But that's not the market. So today, we are the biggest supplier of machines for active alignment and test of photonic components. And these customers we are dealing with, they don't deal with small companies. So they might buy a few machines from you, but they don't see you as a supplier if you're too small who can support them for the next couple of years or next 10 years. You have to have service structures. You have you have to always be at your toe tips to make sure that you are always following their development steps. And now it's turning even. Now they are listening to us, what we are developing going forward, like co-package optics. What do we do in this area? What are we doing what is the next test procedures we are doing? They cannot do that with a small company. So we have to grow, or we will still do like all these little individual machines we did in the past. And this is not what we want to do.
Growing is not only hiring more people, it's not only creating new buildings, it's also structuring the company and the manufacturing in that way. One thing I have seen today when I walk around the manufacturing plant is that the company has become a lot more modular. So when you see the machines, there is a lot more modules, but still it's a whole new unit. How did you manage to have this change of mindset, to have machines that are more modularly oriented, but still satisfying a very particular challenge?
It actually was all a method to reduce our stress, because the stress was always in the software development. If you have too much work on software development, or you have to do everything from scratch. And we are following this path of becoming even more modularized, more standardized for specific markets. There will be always a section doing super individual machines, which is important for us to make sure we will follow what's coming in the future. But everything what's, I would say, commodity today has to be standard. And so we are currently restructuring the company. That will be two different paths. There will be the specialized machine building side and this more standardized machine building side, because they are work-wise completely different. So we have what we're very proud of, our manufacturing and the design center in Estonia. It's a really European collaboration. And that helped us a lot. Would not be here today if we would have not this manufacturing plant in Estonia.
But I also have been very surprised today with your activities in R&D. For example, this activity that I saw in which you're using infrared cameras to look through a silicon chip and being able to place active material on top, so do hybrid integration of indium phosphide on silicon. How important has been R&D for ficonTEC?
Very important. So we were always like running multiple R&D projects with large and also small companies and research institutes. And that is always making sure that we are at the tip of the technical challenges, that we're always staying ahead of the curve, what's in manufacturing a few years later. And we will continue that.
I was indeed very impressed with the R&D activities. And I see that you do lots of R&D with many different universities.
Yep.
And I have to congratulate you on that. And the results of that is public. But I also I've seen today that you do lots of R&D internally. When do you decide that some R&D activities can be done in collaboration with universities? And when do you decide, no, we have to do this one on our own and be quiet about it?
There are specific technologies which we have to do on our own behalf because we see a future in that as a core technology. And what we do in the European projects, it's always like support functions. We are supporting R&D projects, and we are using this to make sure that this specific consortium, if they build a new device or a special new technology, we make sure that it's manufacturable. And we build the machine already for this new technology. If we decide that we have technology which we really focus on ourselves, like this IR bonding with integrated laser soldering, which I think it's a world between active and passive alignment. That is stuff I don't want to develop and disclose to anybody else before it's completely ready. And now it's ready, so we will have our first publications next week. So
I want to talk about the applications now. So in the beginning, you moved from telecom to lasers, and then afterwards, telecom was again the main market, and now new things are coming. LiDAR is coming really strong. Very strong. When did you realize LiDAR could be a really big market for ficonTEC?
I mean, everybody talked about LiDAR, and if you look into the details what LiDAR is about, it's exactly what we do for the other markets. So it's still the same. You place lenses, you place potentially fibers, you connect PICs. So for us, to build a LiDAR machine or a high-power laser machine, or a telecommunication machine, it's the same. There's no difference. It's a different market, it's different customers that you have to adapt to, but for us was obvious that that's our market. And today we're proud already that we have the biggest LiDAR companies or future LiDAR companies as part of our customer portfolio.
And that's very impressive. But I have to say that from your point of view, it's the same building a transceiver than building a LiDAR device. But when it comes to applying the standards, or the telecordia standards for telecom are very different to the standards for automotive. When it comes to placing the machine in an automotive qualified manufacturing center, and most important, when it comes to the price per unit in automotive and the price per unit in datacom telecom, it's also very different. So how difficult was for you to adapt to these constraints, or do they not matter when it comes to have an automation machine?
I would say where the LiDAR technology is today, it's not the main focus. Today we are still in the phase where we are enabling a technology. Going forward, and that's what we are very well aware of, and we are preparing for that, you need to be ready to have a certain price point. Either you have to have the speed or low price for the machine. You rather have the speed for the manufacturing lines. So I think we are ready, but the customers are not there yet to have the quantities. But they will be eventually there, but I think it's another 2 to 3 years out.
One thing that has also made a big difference, in my opinion, for ficonTEC is that you have never been too worried about the volume demanded by your customers. Actually, I have seen some of your machines in companies who don't make 1,000 units per year, and they are doing automation. I actually have seen your machines in aerospace projects, so in space projects. How was it for you to convince companies to invest in automation when they just were making only a few units per year?
I mean, we have this slogan from lab to fab, and I think some of the applications you cannot do. If you want to prove a technology, you have to also show that it's manufacturable in a way that it's automatable. So you have to start with at an early phase with the automation. So if a customer or an R&D team wants to develop a product which they eventually want to bring to a higher quantity, they have to think about manufacturability. So it's actually a very easy sell.
And in addition, not only the companies in large volume, and today you are the market leader when it comes to active alignment machines for large volume. Not only small volume, but I see a lot of your machines at universities, and especially people doing research on, for example, quantum technologies. Those are only going to buy one machine, and they're going to have to customize it a lot. Is it, from the business perspective, is it more an investment, or is more a way to be in touch with the new technologies, or a real business plan?
Again, even for quantum technologies, it's very close to what we are doing already for telecom, datacom, for LiDAR. So for us, it's not a big change. So I think for us, it's already a business today. And again, the machines now are very versatile and flexible, complex, because the customers right now, they don't know exactly how they want to package the devices. But we have already the standard platforms in 4-hole in order to accommodate that to a larger quantity. And we have already customers who are asking for 30, 40 machines for PIC packaging for quantum computing. So it comes. I'm 100% convinced.
It looks to me that what you're doing in quantum today is what you were doing in 2013, 12 with photonic integrated circuits. It's a community that is developing, has huge plans, is developing a technology. They don't know exactly how the chips are going to look like, how they have to package it, how they have to test them. And you are already talking to them about automation.
Yeah, and we need to talk to them because it's an enabling technology. So we help them to package the first chips, to miniaturize the light sources they need, to put the detectors together. So you need some kind of automation, and this is always very important. What ficonTEC is doing, it's not only the active alignment, because there's a lot of companies who can potentially align stuff. It's the alignment and attachment, the whole packaging process, and this is part of the machines. And what the customers are buying is a process with the machine, which is grabbing devices, aligning it, and attaching it, and that's important.
I want to ask also about the automotive market. So LiDAR is here to stay, it's clear, but what I have seen is that LiDAR has been also an opening door for bringing more photonics into the car. And what I expect is to have a lot more cameras, miniaturized cameras in the car. Automation is going to play a huge role there. Are you feeling the same thing? And do you have an idea to have more camera manufacturing out of the ficonTEC machine?
Yes, so we're doing it already since the last 2 years that we have in our R&D. It's one of the topics we do alone, but also with companies like Photonic Sense in Valencia. So they, for example, use our machines to package their cameras. And we are currently developing a very high-speed camera assembly machine, which we will bring out next year. And I think we can really play an important role in that market.
And another very important market is biosensing. So in biosensing, I'm very happy with Rockley Photonics going public, and of course showing their collaboration with a big consumer electronics manufacturer for developing wearables with biosensing technology on it. Are you feeling also the same thing, that biosensing is here to stay and going to the large volumes that we can do?
We as ficonTEC, we don't have too many projects right now. There's a few things we're working on, but I'm 100% convinced that it will be, and this is also one of the reasons why we developed this IR bonding system, because that's a perfect technology for that market. I'm 100% sure it's there to stay and to grow dramatically. All sensing applications, environmental sensing, biosensing, it will be huge for the photonics photonics industry.
If that award was a crystal ball, and you could look at it, and we had this interview like in 10 years, what kind of things would you tell me differently? What is your preferred future? How does ficonTEC look in 2031?
If you see the electronic industry, and you see why the electronic industry and semiconductor industry was so successful, was standardization. And it was because the industry worked very closely with equipment manufacturers, and there were many equipment manufacturers in the beginning of that industry, and there's only a few left. For the photonics industry, I really want to be one of those who stay. Because I think we will see the same in the photonics industry. So, and me together with ficonTEC, we want to be the leading company in that industry. At the moment, I think we are the company, and I hope that is also true in 10 years from now.
I'm sure it's going to be true in 10 years from now. I will come back here in 10 years. I want to ask you about the future of the photonic industry in Europe. I want to know your vision about this. We are growing, we're getting more mature. You already said that manufacturing is coming to Europe. The big purpose of EPIC is that the European industry is sustainable in photonics, that we have the manufacturing and we have the end users. How do you think that the current ecosystem looks like, and can we make it sustainable?
So if I look back in our ficonTEC revenue numbers, so the last, let's say the last 10 years, Europe was always playing a minor role in our overall revenue. The big contributor were US, the other one was China. The US customers shipped the machines to Asia. So pretty much 80% of our machines went to China. Since last year, we are seeing that our revenues in Europe are increasing dramatically, and there are a lot of these machines are going into manufacturing. So we are now literally even with US. Only the revenue, I can only see that from the revenue perspective. And that means manufacturing for photonic devices is moving back to Europe. Or, other way around, what I'm 100% convinced is that you need to help young companies to do the right steps in the beginning. And one of the right steps in the beginning is thinking about manufacturing. Not only about the product strategy, but also making sure, okay, you can manufacturing, and you can manufacturing it in a manner that it can be either in your own lab or into, for example, European contract manufacturer.
A big part of the growing is also hiring people. We're here outside Bremen, in Aachen. There's a lot of industry here. I've been walking around. There's a huge Amazon plant just off the street. Is it difficult to find talent, to find people to hire, and taking into account how multidisciplinary is the activity of ficonTEC? How do you find those people?
It's actually not so challenging to find young talents who coming right out of university, because there's a few very good universities for optics and mechanics here in the area. Especially talking about our R&D team and the automation team, but they are very young and you have to educate them yourself. So you actually have to grow your own talents. It's very difficult for us to hire experienced industry veterans who would help us to bring an outside view into our technology. So it's really something we are looking for. Everybody's highly invited to apply for jobs here in ficonTEC because we need more experienced people in bringing the industry experience to our young team.
Because part of the success here, and I get very excited about this part, is that your people communicate with your customers understanding their application. For example, when we're talking right now about biosensing, and you said, well, it's very important to have the indium phosphide really plugged to the silicon, and we have a good idea for that. Or when you talk about the LiDAR, and then you say, we are using the same technology that we use for the transceivers, because an FMCW LiDAR device is the same as a coherent transceiver module, and that's how we do it. So for you, having this discussion, constant discussion with the customers, understanding their application is key. So that's why these application engineers that you are having now working at ficonTEC or looking for them to work at ficonTEC.
And the knowledge transfer is so important. And this is the reason why I'm looking for this experienced people, because so this is our fastest growing department. The company, the team who is putting the processes into the machine, and they need to understand the application better than the customer. And it's really difficult to teach. So that's really one of our strongest challenges right now.
But you realize, Torsten, that we have gone from give me your chips, I will package them in my machine, to I know what you're doing better than you, well, at least I know your application very well, so I can actually help you with your process so the final product is going to have the shape, the size, the weight, the cost per volume that your customer demands.
And actually it's one of the key selling points today, because now while photonics is moving into the electronics world, they're electronics experts, but they have no clue about optics. So we need actually to tell them how to package and what they need to take care of when they put the optics together.
I want to finish with this question. So the younger generation of entrepreneurs, the ones that are now 20 years old, 25 years old, they want to build the next ficonTEC. They want to build from scratch a company. They have an idea. What advice could you give them?
If you really believe what you're doing, never give up, and be very careful with who you work with as a potential investor. There's a lot of passion, there's a lot of networking, a lot of luck you need to have, and I'm very thankful for that we had the luck on our side when it comes to certain steps, but we would do it again.